All right, so this session is being recorded. I'm going to share my screen real quick. All right, so this is what we were doing last session, which is look at array list as a data structure and how array list is kind of takes care of few of the problems that arrays have, which is adding and dynamically adding and deleting elements. So if you have to make a choice between when to use an array list versus when to use an array, is a few things that you can keep in mind. Is first, do you want to continuously add and delete data from your array or collection, a sequential collection? If you want to do that, then array list is a good candidate. If you don't know how big your data size is going to be, let's say it could be 1,000 elements in an array, or maybe like 10,000 elements. You don't know how many elements are going to be. Then an array list can be a better choices because it can keep growing. But in an array, you'll be bounded by how big of an array was created, at the beginning. Optimization can also be a criteria for choosing which data structure to use. So last session, we stopped at writing a program which goes through an array list and searches for a given string in this case. We kind of had a list of names, and we tried to find if one of the names were there in the list or not. And our method just returned true or false, which means whether the name is there or not there. So we'll expand upon that, and we'll write some more quick programs just to get a hang of how to use array list. And a few of the programs that I had in mind are a bunch of these. If you look at the screen, so it's like find all names starting with R, or any arbitrary character for that matter. We'll discuss and maybe write a program about finding duplicate elements in an array, or finding a non-duplicate elements. So which means is find duplicate elements is you'll be given an array list with a bunch of elements, but only two elements are duplicates in it, and the duplicates will always be adjacent to each other. So how do you find such an occurrence? Or to find a non-duplicate element. So let's say every element in the array list is repeats twice, except for one element, and you need to find which one is that. Find all negative numbers. We'll just talk about it. It's intuitively easy. We'll see how to compute sum and average, and then the reverse the order of elements. So given a list of elements, we'll try to reverse the contents altogether. So any questions before we start writing our first program for the day? All right. If you have any question, feel free to unmute and ask for it. So let's start with the program to write, let's write a program that finds all the names that start with a given character. So for that, let's create a class, and let's call it, maybe not, we can just use a linear search here, the class that we created last time, and we'll just add a method which finds all the names that start with a certain character. So let's say we'll call it private. And what the question is? The question is to find all names. So when there's all names, there could be one name, zero name, or there could be more than one name. So in that case, what should be the return type of our method? Any opinions? Hali, Yash, Parashar, we need to find all names that start with a given character from an array list. So what should our method return?
Maybe you could have it so like there's the letter that you want is a variable, and
Yeah.
then you have to find the variable in each element
Okay.
like that.
But what should the method return?
Oh, strings, right? Because you're just
Well, okay. How will you separate names if you find more than one name in the entire list, which starts with, let's say, character R? How would you separate them out if you return one string?
oh like that. Oh,
Yeah.
I don't know. I was thinking like strings, like what, like each word is a string. Then you just keep putting string one, string two, like that.
Well, so you're saying how do you do that? So if I write string, that's how find names with I create that method, right? And then it takes an array list of strings, which is names, and then it takes a character, let's say C, which is a variable. It can be anything. So is that what you're saying? We should return a
Yeah,
string.
something like that. Yeah, that's what I was thinking.
But if there is, let's say, we have these names, right, wherein there's Shari and Sarah, which are both start with S, and let's say we need to find all names that start with S. So in that case, we have now two names. How would you return two names?
Would you
Yeah,
use
I don't really know.
Boolean?
Come again?
Would you use like Boolean search? I don't know.
No, Boolean can only tell us if there is a. It'll just tell us true or false, which means the list has any name starting with S or not, as an example. But it won't tell us what are those names, right?
Yeah,
So, any guesses?
I'm not really sure.
Alright, so we can. Okay, so now we understand the problem is we need to return multiple results. They all are of the same type, which is string. The names are going to be of type string in this use case. And as we need to return more than one, we have two choices here. We have learned about array, which is a collection of sequential collection of same type objects, or we can use a array list which has result. So we can say this to be an array list of all strings. So so now we can return a list of names, right? So this is one way to return all names. So now, how do we write the body of the method? Is we got all the names as a list, array list. So we'll go over all the names. So we'll say for, the type is string, um, name in names. This is one way of writing for loop. We could have also chosen to write um, same for loop in, let's say, int I is equal to 0, I less than names dot size, and then I plus plus, right? We could also write a for loop in this format, and both are same. You can clearly see the first approach is very intuitive. It is just saying go through all names, individual names, right? The second one is kind of you need to kind of do a math increment, and then you also need to kind of worry about a lot of things. If names is null, then you'll get a null pointer exception here. So you need to care for that. And then the way you need to access element is going to be involving more work. So name. So this is how you'll get elements in the array list. So you'll say names dot get at index I, right? So you need to write so much just to get each element of the array list, whereas the first approach is kind of quick. If your name's array list is null, then the for loop will not run. So at least the program is not going to crash, right? So this is a more optimal way of doing it, but both ways work. It's personal choice at this point in time. But getting back to this, what we need to do is find if the name starts with a given character, right? So, in fact, instead of this being a char, let's do it a string, just to make things easier. So we'll say if name dot character at index 0 equal to, well, let's keep the parameter as char. That makes it easy. Well, if it was string, then the way you would do that is just do a c dot character at 0, and then that's like converting one character string to that individual character. But for sake of simplicity, let's just do it as a char. So we'll say if the first alphabet of the name matches the char, then what we do is need to return an array list. To return an array list, we need to create one array list. So we'll say uh, array list of strings. Oh, array list of string is, let's call it the matches is equal to new array list. So we create a new array list, and then if we find a match, we add it to the array list matches dot add. So what do we add? We add the name that matched, right? And once we have gone through all the elements of the names array list, we return uh, the matches. Right? So um, this is how we, given an array list, we find all names that match a given character and then return a list. Can we optimize this? We can. Instead of array list, we can just say list, and that's fine too. Here, instead of saying array list, we can say list. So this makes it, now you can use the same method for different types of lists. So array list is one of them, but now just by making those few changes, you could use the same method for multiple types of lists. I'm just going to revert those changes because we'll stick to the array list paradigm for now. Now we have our method. Let's quickly run it on a data set here, and we'll say char a match is find everything that starts with a capital S as an example, right? So let's do that. Let's print time, and
Could you zoom in on your screen?
that's better.
Yeah, that's a lot better. Yeah.
All right. So let's print out the findings. Names matching, or we can say names starting with character, and then what character is it? Whatever the match character is, plus R, and then now we need to print everything that matched. So how do we print everything that matched? First, we'll call the method and see how it returns an array list. So we'll say array list of strings matched names is equal to find names with matching characters. So we'll call the method find names. Oh, this has to be a private static. We'll find names matching character. What's the matching character we have is the match. Now we need to print it. There's an error which says expected two arguments but found one. Yes, we did not pass in the names. We did not pass in our data set. So now that satisfies the condition. So let's print the contents of match names. For that, we did write a method which is kind of an utility. Let me see. So see how we had written a method, which is kind of a common thing. It says print array contents. So we'll write something very similar, which prints array list content. Right? So we can't really use that because that takes that method that we have takes an array, but we have an array list. So we can let's write the method here, and then we'll move it to a utility class. That way we can reuse it in different classes. So for now, we'll say private void static void print list contents. It just does one thing, which is just prints list contents. And what should it take as a parameter? It should take a list. It could be of any type, data, and then what will it do? It will simply okay. We're going to say we're saying it can be list of any object essentially. So T is kind of a placeholder. It says any object will just work fine. So we write a for statement for whatever that object is, obj in the list in the data. Simply go and print the contents. So we'll say system dot out dot print. Should we print? Let's just print in one line, and we'll say obj plus tab. So all the contents will be printed in one line, and there will be a tab after that between each element. And once we're done printing it, we'll print a new line. It'll print a new line for us. Now let's call that method and see what output we get. We'll say so we call list contents, and we'll pass in the match name. Like this. So once we have written that, let's go ahead and run the program. So there it is. It matched two names, Sherry and Sarah. They all started with first character being an S, and we missed one thing was it's kind of well, it's cosmetic at this point in time, but essentially, see how the names do have a tab, but then in this case looks like a space. So to make it look better, we can just add a comma just in case to make sure the names are at least separated by a comma. So let's run it again, and now there it is. There's a comma, and now you know there are multiple names, and you can kind of go back and forth and make it prettier. But that's not the point here. Now we know that this method works. It found two names that start with a character S, but let's change the character to a lowercase s, right? And then let's run the program. Well, there is no name that matched character lowercase s. Why? There are two names which have S, but then see um, the first character is um, uppercase, right? Um, so that does not match with the lowercase. Now, what should we do for this method to return the names no matter what the case is? Any guess? So it's quite simple actually in Java. So what we can say is either the character at index 0, which is the name, starts with the given character, or names, whatever the name is, dot uh, convert everything into a lowercase and then say character at index 0 is equal to whatever character we need to match, right? So will this work? Well, it'll work for the cases wherein, let's say you have these names which start with a low uppercase. When we do the first check, does a uppercase S match a lowercase s? It does not match. So this condition will not be true, and it'll check the other one, which first converts all the names to lowercase. So it'll convert these names to lowercase and then compare the lowercase s with the character C, which is S in this case. And that matches, then it'll add to the list. But when will it fail? So it seems like it's working, but there's a catch here. It'll fail when, let's say, these names were starting with a lowercase, and what we were looking for was an uppercase S match. So in that case, this will fail, is because we are not considering the uppercase variation of it. We're assuming that the name is going to start with uppercase. So let's fix that problem, and we'll say to uppercase. Um, Uppercase. Okay. So now what we are saying is, no matter what casing of the names are, first convert them into an uppercase and see if it matches the match character. Or if that doesn't work, then convert the name into lowercase and then see if the character matches. If neither of the two match, then it means there is no match found in the list. Now, the question is it efficient? Well, it is not efficient because for every element, we first convert everything into an uppercase string and then everything into lowercase string, which is too expensive process. But this is one way to do it. You can always, so right here, when you run the program, you see the two names actually matched. One name has a lowercase s, and whereas the other name has uppercase s. So this method did work, and I'm sure there's a better way of doing it, a more efficient way of doing it, and you can explore that option, in your free time. That's a simple program to solve the given problem statement of find all names starting with. I had R in my mind, but it could have been anything. So we did that. Now let's look at find duplicate elements. So the problem statement here is, given an array of unique elements, right? So the array has no duplicate except for one element which repeats. And whenever that happens, the repeated elements are adjacent to each other. So we need to find if the array has any duplicate element, and if there is, then what is that duplicate element, right? So you guys can unmute and give ideas about how would you approach this problem. Heli, Parashar, Yash.
Yeah.
How would you, how would you think of writing the second program, which is find duplicate elements? So let's say Let me give
So
an
like find
example.
two of the same name.
Um, so let's say I have, let's say the example is uh, cat, right? So in this case, all the elements are unique elements, but
Mm-hmm.
one pair is repeating, and whenever this happens, the repeating elements are always next to each other. So given this background and this array list of elements, how will you find duplicates in from this?
Wait, so I just have one question. So you said that the duplicates would stay next to each other?
Yeah, if the array has unique elements, but sometimes it may have duplicates. But whenever that happens, the duplicates will be next to each other.
Okay. I guess one way that we could do it is that, yeah, I think I have an idea. So you can go for the first value. So like, and then, so in this case, if it's 95, then you check the value one in front of it and one behind it. And if it matches, then you print it. But if it doesn't, you don't. And then you just keep going farther and farther until you find duplicates.
Okay, and then how would you return the result as?
Int in this case.
And if there are more than one duplicate elements,
Um, what did we do for the last one for that?
we created an array list as a return type. Um, so we said these are all matches, and then we returned that. So every time we found something, we added to the array list and returned it
Oh yeah, yeah. I
to a
guess you could do
column.
the same thing here. Then you could just add it to a array of integers instead.
Could
Okay.
you, um, sorry, could you like go through, like, could you go through each of them and just look at one of them and then see if like that one has, like, just look through the list and like see if
Mm-hmm.
that one matches any of the other ones in the list, and if not, you just kind of put it aside or like just kind of forget about it. Is there a way to do that?
Yeah, you can do that. That will work too. So what you're saying essentially is take 95 and then look into the remaining list and see if 95 occurs anywhere else, right?
Yeah.
And if it does, then we add to the list, then move on to the next element and keep doing that. That's another way of doing it. Yeah. All right.
I have
So,
a question.
yes.
I have a really weird problem in my IntelliJ. For some reason, my cursor is showing up as like a white box, and every single time I click enter, it doesn't enter, it just moves.
Did you press the insert key on your keyboard by any chance?
Insert.
Do you have a
Yeah, that was the
Windows?
problem. Yeah,
Yeah.
yeah, that was the problem.
Okay.
Yeah, that was weird.
Awesome. So one less problem now. Heli, let's talk about your approach. That is something which will give us a solution, and that's a good approach. But there's a catch to that. Can you so there are two things happening here. First is we have this additional information that the repeating elements are always going to be adjacent, right? So when we know that, then if the element next to 95 is not 95, then we'll not find any 95 in the whole array list, right? So we really don't have to go through the whole list. Um, Secondly, let's say if the repeated elements were spread all around in the array list, in that case, we had no choice but to go through the entire array list. And that would be so inefficient is because now we are comparing each element of the array list um, with every other element. Right? So it's kind of bubble sort. We'll be running into an n square complexity problem. So it's not efficient. There are better ways to do that, but out of scope for the AP course. In this program, we'll live with the fact that the repeating elements are going to be adjacent to each other always, and there could be more than one repeating elements. So let's quickly write the program now as we understand this. For that, let's create a class, and let's call it find. Don't say find duplicates. Okay, let's just call it find duplicates. All right. What I was thinking is we have few problems around finding. So why not just create a class which probably is about kind of finding elements in an array, and we'll just look at integer type things. So we'll just create a class called find elements. Uh, so that it makes it all finding related problems will solve here. Our first problem is to find duplicates. So we'll say it's a private static. Well, call it public because we need to call it from the main method. Find duplicate elements. Elements. And what does it take? It takes an array list of integers data, right? What should it return? As it can be more than one elements, it is going to return a list of all integers which are duplicates, right? So once we have that, now can we use the shortcut method of for loop here? Not quite easily, just because we need to compare the current element with the next element, right? And for that, which means we need to have access to two elements in the array list, right? So we really can't use a shortcut method. We'll have to use a traditional way of going through the for loop or writing the for loop, which is integer I starts with 1, I less than data dot size. That's
Wait, is the package ARR list, is that already made?
we made it last session, but you really don't need to have it. If you have your code from the previous session wherever it is, just create a new.
Okay.
Yeah, create a new class there, but we already had a find elements in the array, in the array package. So if there's a conflict, then create an array list package and then create a class in there.
Okay.
Yeah. So why should we start at 1? Why not 0? I mean, well, we can start at 0 too, but we'll start at 1 and we'll see how easy it makes the logic. And what we are trying to, this is an example array that we'll be looking at. So what essentially we are doing is we are starting from number 82, not from 95, which is at index 1, and we are going all the way to the last element. And we'll take both ways, which is starting from 0th index and from 1, and we'll see which one is easier. This is my way of, I prefer this one. So we know if the repeating elements are always going to be adjacent to each other. So if the data at index okay, whatever data is at index I, if that is equal to data dot get index of I minus 1, if that's the case, then we need to save the duplicate element, right? So we'll say array list of all the integers uh, duplicates is equal to new array list, right? And then when we get a match, we save that to the duplicates, right? Dot add go data dot get where index I is, right? So now we add to the duplicates and then we return the duplicates. That's as simple as it can get. Now what are we doing? We are starting at index 1, which is at 82, and we're comparing if that matches 95, where it doesn't match. So we do an I++. Now our I is 2. Does it match with 82, which is at index 2, and then whatever is at index 2 minus 1, which is 1? Do these two match? Yes, it matches. Then we add it to the duplicates, and we keep going in the list, right? Any confusion about this? Uh, uh, let's
Wait, I
let's
actually
write a
have
sample.
one question.
Yes.
So we haven't found like the part of like checking both sides yet, right? Or have we?
Come again.
Like we haven't gone to the part where we check if there's duplicates next to each other, right? Or have we?
So see, it's right here. We say if the element and the one prior to that, if
Oh,
they
no, no,
both
no,
are
yeah,
same,
you're right. I just didn't see the equals for some reason.
yeah.
So shouldn't we
So
check for I plus one then two or no?
so we are comparing I and the one prior to that, right? Not on the other side. So if you want to use, let's say, so what I'm doing is instead of starting at 0, I'm starting at 1 and then I'm comparing the one next to it, like prior to it, and then I increment my I. So now I check the prior to that, and I keep doing that till I reach the end. So essentially I'm doing the same, but then instead of doing an I plus 1, I'm doing I minus 1.
Is that better? Because wouldn't it be simpler if we had I equals 0? Because then 95 you could check 82, and 82
Yeah.
doesn't like that.
Yeah, so essentially it's same. Let's say this is what you're saying, right? So if you start at index I, now how far should the I go? Data dot length or size. Should it go that far? It cannot go that far. Is because now when you reach the
Yeah.
end of the array, you are right there, and then you're going to compare I plus 1, which is going to give you an index out of bound exception. So essentially you need to do that and then do I plus plus, right?
Mm-hmm.
So
They're
you're
very
saying
similar,
you,
right?
yeah, it's very similar. But now you need to keep this in mind that you need to subtract 1 from the size is because you can never go, kind of to the end, because the moment you do I plus 1, it is going to give you a null pointer index array index out of bound exception, right? So both
Yeah.
are same. These two will do the same thing. Um, The only thing is in here you don't have that one extra math step,
Yeah. Okay.
right? Um,
Mhm.
but both are fine. So in the later approach, and what you would do here is you'll say if data dot get well uh, get get at index I is equal to data dot get I plus 1. You'll put the same duplicate logic here. So essentially what we're doing is we start at 0 and we say this element compared with the next one, if that matches, or when we increment I, we compare to the next one. So yeah, both will do the job. All right, so let's comment this out instead of deleting. Now let's write a small program which tests our implementation. So we'll say public static void run, and we create a array list of all integers. Solid data is equal to new array list, right? So we create a new array list and then we add elements to it. So let's add the elements 95 data dot add 82, and we can just copy paste that. This is 39, 61, 44, 24, 10, 30, and 47. We really don't have to have this big of an array for testing, but just for the heck of it, and we'll say system dot out dot print line on ends of array list. Let's print the contents of array list first, but remember we had this method which prints the content. We need to use the same thing, so we'll create another class and we'll say array list utils. ILS utils, right? So we create a new class. We call it array list utils, and it is just to have helper methods. So we are going to take that from that class and paste it here. So it's public, so it's visible to everyone who wants to use it. We got a problem at linear search is because now it can't find the print this. So that's because so that's because we need to add the import here, which is array list utils and a method name. Right. So let's go back to this and let's print out the contents. We'll say print the name again. Just print list contents, and we'll pass. Why is it not finding it? Is because we need to import the class, and the class is array utils dot array list utils dot print list contents, and we'll say print it has. And now let's call our method
Can
find
I
duplicate elements.
Print list contents thing again, like in the utils part?
There.
Also, I had one question.
Yes.
For the data for the array in the array list, why did we do the data dot add like every single time? Why can't we just put the array like normal?
Because array list doesn't have that method or way of doing it.
Oh, okay. Okay. Can I still see the the print list contents. Really cool. I have an error under list. I think it's because I don't have the. Oh yeah, I know why.
because your import.
Hmm. Yeah, I'm good.
Okay, so let's go back. Uh, so there, in fact, so this is what is in the AP coursework, but there is actually a way to do uh, the same thing, which is to add everything in one go instead of calling so many ads. Um, and the way you can do that is you can say integer. I'll call it data all just to distinguish it, and you can say um, array. See, there's arrays, arrays dot as list, and then you can say 95, 82, 82. So you can do the same, so on and so forth. Yeah, so there it is. It will let you create one, like an array list in one shot. But then this is not in the syllabus, so I didn't go over it. But there's a way to do that, especially in the modern Java language. So let's stick to our ways, and then we create an array such, and then we print the contents, and then now we call our method, which is to find duplicate elements, and then we pass our data to it. This method returns an array list which has a result. So we'll say array list of integers, which is the result is equal to that, and then we'll print out the duplicates. So print dot print line duplicates are, then we say array list utils dot print, and then print what? Print all the results, right? So we print the array, and then we perform the operation, and then we print the result, right? So let's to run this, let's go back to our main, and from there we're going to say zoom in a little. We're going to say array find elements, dot run. This will run our program. Let's run it, see what happens. We expect number 82 to be printed as a duplicate.
Wait, where did you put the run statement?
So I created a run method in the class, and then I went to the main, wherever my main is, and then I added that line there.
Find elements.
Yeah. So I had two classes with same name, one in ARR package, another in ARR list package.
So is
So
it
make
just
sure.
the class name?
Yeah, it's just a class name. Yeah.
Okay, that's it.
Yeah. But make sure you're taking it from the right package if you have
Yeah.
duplicate class names. Right?
Mhm.
So once you have that, you can run it, and then it does give the duplicate, right? All right. Any questions?
Oh.
No questions. All right. Moving on. So let's move on to the next one. Find non-duplicate elements. So what this says is we'll not write it. We now know how to do that. We'll just discuss it. Let's look at a use case, right? So let's look at an example of an array list like such, right? So, so in, excuse me. In an array of such kind wherein every adjacent element is a duplicate, sometimes you may end up with one element which is not duplicate, right? So let's well, looks like every element in here is a duplicate, so we'll not find anything. But look, let's look at this example, and we see that every repeating every number is in pair except for the last two, right? So the question is to find what is that non-duplicate number. So in this case, essentially there are two numbers that are not duplicate, 47 and 9, but the answer should have been 47 is because instead of 9, that should have been 47. So it's 47, which is a non-duplicate element in this case. It's very simple. Any guesses on how to do it, Haley? Yash? Anyone? Parashar?
For non-duplicate, I guess you could just do the same thing, but the opposite kind of. Like instead of doing it like maybe make it into a boolean this time instead. Uh,
Um, yeah, you're right.
yeah, like
Um,
you could have so for example, if you have three, so then if like how we did it, if integer is equal to one,
yeah,
three, the one before it is three, and then you just keep doing that. And then when you
yeah,
get to 47, when you get to nine, you see that it's not like that.
yeah.
And then you go back and then it goes through like if it's equal, if it's not equal, then you print it, I guess.
Yeah, well, that will work, but then there's a problem with that approach. The problem is in this case, let's say, where first two elements are 3 and 9. Now, when you start your program, it compares 3 with 9 and says, oh, this is a match. So it's going to add to the non-duplicate list. It'll add 3 to the non-duplicate list. And now it'll increment I. So your I is 1, but that's 9. So it is going to compare I with like I plus 1, which is 9 and 27, and it'll say, oh, even this doesn't match. So it's going to add 9 to the list as well, right?
Wait, I was thinking of the first method, like where it's I minus one, so I is already equal to nine. Oh, but it's the same
Yeah,
thing.
it's the same thing.
Yeah.
So
Hmm.
how can we solve that problem?
Um. Oh, maybe once you like. Okay, yeah. Maybe once you find a non-duplicate, you add two instead of one to I.
Yeah, that's right. That's a solution. You should add 2 instead of 1 to I. And in fact, if you look at our implementation, adding 2 would have been an optimal solution as well in this case. So you got it right. So the trick here was the first approach worked fine in this case, whereas it would have failed in this case, because we had to increment by 2. So these are like subtle differences, or these are like those little things that a programmer has to be very careful about, because it's essentially similar sounding problem, but the solution has just a tiny catch to it, right? So writing robust programs is what we should aim for. Find all negative numbers is intuitively very easy. Is because we just need to see if the number is less than 0. So that's not a big problem. Compute sum and average, right? So how would you, given an array, you need to write two methods. One which returns you a sum of all the elements, and the second one returns an average. So, Hallie, do you want to you know, talk about how would you do this in the program? Hallie? Well, there's one catch to this is if you have a large array list, or array list has large integers in it, as an example, then the sum may exceed the max limit of the integer, and then there might be an overflow. This may apply to other data types as well. So we need to be careful about um, that part. Is our sum of all elements should not exceed the max value of integer. Similarly, for average, if we are taking an average of all the integer type elements, the average can be a fraction. And then if we're returning an integer, then we're losing the fractional part. So we have to be careful about that, what return types we choose. Right. So simple programs, but they require some care. The next is reverse the order of elements, which is given an array of elements. Let's say that, or you know what? Let's look at a different example array. So let's say our array is such 3, 27, 77, 17, and 47. How do we reverse the order of elements, which is our array should be 47, 17, 77, 27, and 3. How would we do that? So there are actually two easy ways to do it. The easiest is to create array, to create an array list, and then starting at I is equal to whatever the length minus 1, all the way to the 0, and then we just keep inserting those elements into the new array list, and now we have the reversed array, the reversed array list. The other approach is to swap the contents, and then so we have I and j as two indexes, and then we swap their contents, and we increment I, we decrement j, and we swap their contents. Right. So let's quickly write this program. It's easy. Hello. Did anyone say anything?
Sorry, no, my mic was on.
Okay. All right. So let's quickly write the program to reverse order of elements, and we're just going to repurpose this class. We don't want to create another one, but technically we should have. This is just an experiment. So in the name of science, we'll just write a program here. So we'll say public, and then how do we want this to be done? Should we return the reversed elements, or should we reverse the order of elements in the data set itself? I think in this case, let's return one. We'll say integer, and then we'll say reverse my data set, right? And then what parameter will it take? It will take an array list of all integers, and then whatever data you need to reverse. So this method is going to take the data and then return you a result, which is the reversed form of the given data. So the approach one that we talked about is the simplest of all. And the way we do that is we create an array list and we'll say array list is of type integer, and uh, reverse is equal to new array list, right? So we get a new array list and then we go in a for loop. We say int I is equal to um, we create a variable called int j is equal to 0, right? And then our I starts at data dot length or whatever size is minus 1. We keep going in the loop till I is greater than or equal to 0, and I plus or I minus minus, right? So we are going from the end of given data all the way to the beginning of it. And while we do that, we add oh, we add the element. Do we need in J? We really don't need this. We can simply say add whatever the value is at at the given index, right? So we know that add always the add method adds to the end of the array list. So when we create a new array list, it has no content in it. So when the loop starts running, the first element is the last element of the data. I is data dot length. So it gets that and it adds to the array list as a first element. And as it keeps going in the loop, all the elements will be added one after the other. So now we'll have a reversed array list. So we can return the result. We can say our reverse list is so, right? Is that simple? So let's look at another way of doing the same thing. Array list integer and then reverse data set in place. So we are not going to create. See how in the previous approach we created an array list, a new one, and then returned a new array list. But in this case, we're not going to create any new array list. We're just going to do it in place. So how do we do that? We create an array list of integers. We take that as the input. Let's call it data, and we'll say integer swap is data at index 0, right? Just it really doesn't have to be that. It can be, something. We just need a variable to kind of uh, 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 to be so that we can use it to swap the contents. We need two indexes, I, which starts at 0, and then we have integer j, which starts at data dot size minus 1. So this starts at the end of this is the end of array list, right? And then this is start of list, right? How do we do? We say while I is greater than equal to j, well, is less than equal to j. So while I is less than or equal to j, what do? We keep swapping the elements. Whatever is at I and j, we swap them. So we say our swap is data at index I. We get that, and then we update the data dot set index I. What do we set that with? Is whatever is at index j, right? So now whatever was at index j is copied into at index I, and similarly, we'll do a data.set. What do we put at j? We put whatever was in the swap, which is whatever was at I. So this is a simple logic to swap the contents. So now as we have swapped I and j elements, what do? We increment I.
I have a question.
Yes.
So do we really need the swap variable?
Um,
Because couldn't you do it? I mean, I don't know, because I feel like the swap just makes it weirder. So like, couldn't you do instead of j as j and swap, couldn't you do j comma data dot get I? Or what does that dot? Or is it because I changes at that point?
yeah. So the moment you copy the content of j into I, whatever value was in I is lost. So
Okay,
you
so
need to save it somewhere.
okay.
Yeah. Yeah. There is a trick to swap elements without using a third variable, but then that's too much of optimization. You know.
Yeah.
So yeah, so that's why we need that swap is to save the element at I before we replace it with j, and then use that to replace the content of j. And once we have done that, we increment I, we decrement j, and now we have the array list reversed in place without creating a new array list variable, and then we can return the same array list we got as parameter back to the user. So, which one is better? Well, both will do the job, um, but it's programmer's preference. If your data set is really huge, then you may not want to implement the first phase because now you create a temporary data which is equally large just for the swap mechanism. So, right. So those could, depending on what your use case is, a programmer may choose one or the other method to solve the same problem. So it's always good to have multiple solutions at hand. Let's look at another program. Now this is it's pretty interesting actually. So we are a bunch of engineers, and uh, a owner of a horse barn has reached out to us, and they want a program which can help them manage their barn, and they have these requirements that they want the program to meet, which is they have n number of spaces where horses can be put. In each space, there can be only one horse. So let's say a barn has, let's say, 10 these cubbies, wherein in each one there can be one horse. So it can have 10 horses. Each horse has a name and has some weight, right? Those are only two things they want to know about is what is the name of the horse in a given space, and what is the weight of the horse. And no two horses in the barn have the same name. So every horse has a unique name. And what they want us to do is to write a program to find the space where a horse is. Uh, So they want us to write a function which is public integer find horse space and given a name, and we need to find where does the horse matching this name exist in this barn, and return the space number where the horse is. If we don't find any horse with that name, we just return a negative one, right? As simple as that. Second is what they want is a method which says add horse to barn. So if let's say they bring in a new horse and they try to add that horse to the barn, The method should um, return a zero if there is no empty space, all the spaces are occupied, you can't add a new horse to it, or return a negative one if a horse by the same name exists. If none of those two happen, then we put the horse in a space and we return the space number. All right. Third ask is get number of empty spaces in the barn. So they want to know, let's say before getting a new horse, they want to find out if how many horses can be accommodated. So they can just say public in capacity, and then the program should return how many empty spaces are remaining. So if there is no empty space, then we should return a zero, right? Um, The next is to move all horses adjacent to each other, return number of empty spaces. So they'll ask us to consolidate all the horses. So let's say there are 10 spaces for 10 horses, but there are only 5 horses in the barn, and they may have horses may have empty spaces between them. So the owners might want to bring in all horses into adjacent spaces, so they can have the remaining empty spaces all at one end. So how would you do that? So this is a simple ask. Right? Any questions about the program? No questions, right? So let's um, let's talk about it then. How what data structure will we use to store this information? Guys, unmute your mics and uh, give us suggestions.
For the first one, for the first part.
For the entire program. Uh,
Oh, routine.
So I was thinking for like the horse, like to find the space number where the horse is, you
mhm,
could like insert the names into like just an array list or something, and then you
mhm,
could find its index or like, and then add one, and then that would be the space it would be at. So it would be starting at one,
mhm,
and then from there you could just like find the index and then add one, and that would be the space it's in. I don't
mhm.
know.
Um, you're on the right path. There's one catch to it. Now, the catch is in array list, let's say there are 10 horses, right? So all the 10 spaces will be occupied. And now the barn decides to get rid of horse on the fifth space. So if you have an array list and you do an array list or delete, then all other horses from 6 to 10 will be moved one space adjacent, right? Um, so we'll end up rearranging the horses every time a new horse is added or a new horse is deleted,
Oh, okay.
right?
Yeah.
So the array list may not be the right candidate, but now that's a if you look at the last problem, which is to consolidate, maybe array list can be used here. So we can store the horse information in a different data set, or and then save it all into an array list, which will consolidate all that for us and then convert it back into the data set, right? So we may use array list in at least one of the methods. But yeah, so when we get a problem of this kind, uh, we have to first think what data structure do we want to use. If we start with the wrong data structure, we'll find it very difficult to implement our program. So if array list is not the right candidate, what is a better candidate? Any takers for this? Um, well, there are a few hints in the question. First is horse barn has n numbered spaces, right? So the number of spaces are fixed. Now, the array data structure actually has a fixed length, right? So That's one hint that you can get from the program is maybe array is a choice of data structures because um, it has fixed length. Secondly, is there can be empty spaces, right? So it means there can be gaps in the like few spaces may not be occupied by horse. So in that case, array list won't allow us to do that, but array will. So based on just these two um, hints, we can say that maybe array is a better candidate. Now we need to store two things here: name and weight, right? Uh, so how will we store two things about a horse inside of an array list, or sorry, inside of an array?
Instead of having two arrays, I mean, instead of having one array, shouldn't you have two arrays, but then like you have the name and then the weight in the same index?
You can. Now let's say we are saving only two elements, but how about if we start saving more information about horse, like color or when was the horse last fed? So we'll see that quickly it becomes impractical to have so many arrays of individual characteristics of a horse, right? So
Mm-hmm.
let's say we wanted to save color, then you would have another array of color, right?
Mm-hmm.
And managing that becomes difficult too. So let's say if you move a horse from one space to another space, you have to make sure that you have moved everything from all other array of that related to that horse into the right index. So that's too much of management. Can there be an easier way of doing it?
The only other way I could think of it is um, like maybe in the array you put the name of it and then the weight right after, and then you move the stuff by getting both of those two indexes. I don't know.
Mm, no, you maybe not. You cannot create an array with two dissimilar types. One is name is a string while
Yeah,
weight is a integer in this case. So you can't have an array like such. It has to be a same type.
yeah, I'm not sure then.
Okay. Hallie, do you have a guess on how will we store these two information?
No, I'm kind of out of ideas.
Out of ideas. All right. Yash, do you have any intuition on how can we do this?
Um, no, not really. I'm kind of confused.
So we decided we'll use array to store to implement this problem solution. Now the problem is how do we store name and weight of horse in an array? And then potentially there could be more color or whatever related to the horse. We don't know. Uh, so how would you store multiple information about one entity in an array?
Could you do like an array inside of an array? Is that possible?
Uh, It is possible, but it will not work in this case. Is because the name is string, so create an like at some point you will end up with this problem of having two dissimilar types, um, and an array really doesn't support two dissimilar types.
Is there is there any way you could like do two separate arrays and then just call them together at the end? Or like I don't know how to explain it, but like
Yeah,
where like and you put them like with the same corresponding like barn number or something, and then when you like at the end when you're like supposed to call it out, you kind of just add them together. If that makes sense.
yeah, so it can be done that way. So in this case, now we'll have two arrays, one which will have horse name, and at the same index in the second array, which will be storing the weight of the horse. But let's say if we add color to the horse, then we need to create a third array with color in it. And if we keep adding such attributes to the horse, we'll keep creating so many arrays. And now we have to make sure that at every index, the characteristics match for the horse, right? So that becomes too much of work. So the better way to do this is to create a class called horse, and the class can have name and weight. And now you can create an array of type horse that we have stored two elements, two characteristics of the animal in one array. So let's say if we add another attribute called color, our array doesn't change. We just add color to the horse class, right? You'll agree to that?
Yeah.
So, well, that's where the classes came to SQ. Let's quickly implement it. Right. So let's create. Well, this is a problem more catered towards the array use rather than array list. In fact, you know what? Let's create a package. Let's create a new package and let's call it barn, so that horse-related program remains in that package. We'll call it as a barn, and then in the barn we have, as we discussed, we'll have a class which will store information about a horse, right? We'll create a class called horse. That's it. Now, what does horse have? It has a name, right? Private string name. And what else does it have? It has weight as of now, right? So it has an integer weight. For simplicity, we are keeping weight as integer. It could be float or whatever, but just for the sake of it. Now we want the user to give us the horse name and weight when they create a horse class. So we'll say public, we'll create a constructor, horse, and then we'll ask for name, and then we'll ask for the weight, right? So we take that from the user when we construct the object, and we'll say this.name is equal to name of horse is whatever the name has user has provided us, and the weight for this horse is whatever weight the user has provided, right? So that's how this is as simple as it can get. So now we have a class which does that. So now we created our class, but how do we get the value? If you want to find out what is the name of this horse, how would you do that? So we create a public method, and we'll say string get name. Right? So when someone calls this, we'll return the name of the horse. Similarly, how do we find out the weight of the horse? We'll create a public integer get weight. We'll say get weight of the horse, and then we return the weight of this horse. Right. So this is our simplistic horse class. It saves name and weight. Now let's create a barn where the actual program is going to be. So we'll call it, what type of barn is it? It is a horse barn, right? So we'll just call it horse barn. Yeah. And now we said we'll create we'll use an array of type horse. So we'll say private horse array, and then we'll call it space. There's a better way to do it, but we call it space. But for now, we'll say each space is of type horse because we're just storing horse there. This is not. This is just to prove the point here, right? Now, how big should the barn be? How many horses can it accommodate? We don't know. So we'll ask the user to provide it to us. So we'll say public horse barn, and then we say if you want to use our program, first tell us how many horses do you want in your barn, right? So we ask that to the user, and when user provides that, we create our array list. Our array. We say new horse of how many spaces of whatever number of spaces user wants. Why is ah so it's complaining about, see how the name kind of matched. It confuses Java. Well, it confuses me too. So we'll just change our variable name to spaces, and there it is. So we say let's name it different. Let's call it capacity. That's the capacity of our barn. So when we know how big, what is the capacity of the barn, we create a array of so many horses, right? Now we'll start our implementation. So what all does the user want? As for the problem statement, we need to implement find horse space. So we need to find the space where horse is with a certain name. Return -1 if no horse with that name is found. So that's very simple, right? So what we need to do is we need to do public integer, and the name method is find horse space, right? So we'll say find horse space wherever horse with a given name is, right? So how do we do that? Well, it's pretty simple. So we'll do for horse in our spaces is will that okay. So we'll say if horse dot get name dot equals given name, then what do? We need to return the index of where that match happened. So well, so this shortcut method of for loop will not really help us much. So let's do it the traditional way. So we'll say for int I is equal to 0, I less than whatever number of spaces dot length, and then we do a I plus plus, right? Now we know that the array can have gaps in it, so we need to be careful. So what we do is we say if, okay, before we do that, we say horse, right? And then we say, we ask for what horse is at space I, right? We get that horse. If the horse is not null, which means if the space is not empty, and horse dot get name dot equals the given name, it means we have found a match, right? So what do we do? What do we do when we find a match? We just return whatever index we found the match at. What happens if we don't find a match? So if we don't find a match, we return a -1. That's what the contract is, correct?
I have a array under horse.get name.
What do you have? What does it say?
It says cannot resolve method get name in horse.
So did you in the horse class? write this get name method, and then that problem should go away.
Yeah, because I had the uppercase G. Yeah.
Ah,
Okay. Thanks. I just have one question actually.
okay.
So what is the in the horse barn? What is the horse? Like, so the capital horse, that's the
This,
array, right? And then the lowercase horse is like the horse in that spot.
yeah. So you're talking about line number 11, right?
Yeah, 11 and then yeah, 11, yeah.
So essentially, in each of the spot there is one horse, right? So the type of that horse is it's a horse type object, right? So I'm just saying whatever is a horse there, get me that horse, and then if there is any horse, which is if it is not null, maybe let's call it animal. Just we say give me the animal who is at that space, and if there is an animal, which means it's not null, and the name of the animal is equal to whatever name we're looking for, we found a match, else we did not find a match. Does that help? So every spot has a horse in it, right? Now, what horse? There's an animal in there, and what type of animal is that? That's a horse type animal, correct? So we need to. Okay, so how do you find out if at a given space there is an animal or not? So if there is no animal, then that space will have null value in it, right? Because arrays have null in it if you don't assign any value to it. Now, if there is an animal, then that animal, we need to find their name. So what we do is, in every space, we expect an animal of type horse to be there. So we say whatever is, we create a variable animal of type horse, and we say whatever animal at that space is, assign it to the variable. And now we check if the variable is null. If it is null, then the animal doesn't exist in that spot. Uh, and if there is an animal, we check if the name of the animal is equal to the name we're looking for.
Okay,
So
so they're
just
just
a
the name.
temporary variable, yeah.
Yeah, okay, that makes sense then.
Yeah, if you just go for whatever space dot get name, you can also do that. But the problem here is dot equals. But the problem is if there is no animal at that spot, then you'll get a null pointer exception because this is going to be null, and then it'll be a null pointer exception, right? So that's why we store the content into a temporary variable first, and then we do operations on that temporary variable. So if the first horse doesn't match, then the for loop is going to go second time, and it'll look at the second horse. So this animal value will change to the second horse now. All right. Let's implement the next method, add horse to barn. Now the catch here is we have to return 0 if it's a known, there's no empty spot. We need to return -1 if horse by same name exist, which means you cannot have two horses by the same name, correct? So let's write that. It's a very simple line of code actually. So we'll say public add horse to barn. We'll say we will ask the user to give us a horse. In there there is we take name and weight, which actually we can take. We can just take string name and integer weight of the horse, and then what we can do is we can create a horse object, horse and new horse. To create an object, we do a new and pass name and weight to it, right? So we created a new object, a new horse object, and now we try to put it in the barn. So to do that, we first find out if a horse by the same name already exists or not. How can we find out? Well, we have a method to do that. So we can quickly call that method and we say int the spot where, get me the spot where this horse is, if it already exists in the barn. So we define horse and we'll pass a name. So if the animal exists, if a horse by the same name exists already, we'll get a non-negative return, right? So so what does it ask? Return 0 if no empty, minus 1 if a horse by same name exists, right? So we check if spot is not equal to minus 1. So remember, find horse space returns a -1 if a horse is not found. So we expect this to be in -1. So if horse already exists, we don't put it. So if it is not a -1, which means a horse with the same name exists, we just return -1, saying, hey, we can't put it in the barn because a horse by the same name already exists. At this
I have
point,
under string
yes.
for me, for you 21, I have an error under
Okay.
string name. It's saying that it's expecting a parentheses or a semicolon for some reason.
Do you have the previous method parenthesis closing like such?
Yeah, I do.
Do you want to share your screen?
Yeah.
Okay. So what is happening here is I think so. Click on 9. Yeah, see the bracket, the curly braces for the method is not closing. So yeah, there it is. Now the problem should go away.
Extra them. Wait. I got it. Because then here it says that I'm missing a return statement.
Where does it say? Okay, yeah, that's because your return is at line 17. It should be after the line 18 bracket, curly braces. Yeah.
Okay, that's okay. Okay. Thanks.
Right. Yeah. All right. So at this point here, if our spot uh, is -1, it means the horse by this name does not exist in the barn. So now we can try to add the horse to the barn. But before we do that, we need to find out if there is any space in the barn or not, right? So how do we do that? There are two ways to do it. In fact, okay, let's do it. Let's do it, which is apt for this mechanism. So we'll say for, we'll say for uh, for integer I is equal to 0. So we just look at each space and see if there's an empty space, and we put the horse in that. Right. So that's what we're doing. So we're going through each space one after the other. I less than our variable is spaces is where all the horses will be. So spaces dot length. So we go through the whole array and we say I plus plus. And if if at space I is null, if there's nothing at that space, then we add the at ith index we add the new horse. New horse that we created at line 22nd, we add that there. And then now as we have added the horse, we'll say return the index at which we have added the horse. Now, if the barn is already full, as per the contract, we need to return a 0, right? So what does the problem statement say? It says, okay, so here it says, return a 0 if no empty space is found. So when will that happen? It will happen when we have gone through the entire all the spaces and we have not found any empty space. So the loop will end and we'll return a 0. So there's no space available, right? So let's look at the next problem statement. What it says is get number of empty spaces in the barn. So what is the capacity of the barn? So we need to find out how many spaces are available. So if we need to put a new horse, how many new horses can we put? So we'll say public integer, and it says capacity. We call it barn capacity. How do we find the capacity? We'll create a variable called capacity is equal to 0, and then we'll just go we'll look at each spot and see if how many of them are null, right? So we'll say int I is equal to 0, I less than our number of spaces dot length, and then I plus plus. We're going through each space and finding out if at any space, if it is null, it means that space is empty and we can put a new horse in there. So we say our capacity is, we increase our capacity by 1, and at the end we return whatever our capacity is, right? So that's a very simple way of finding out if how many more horses can be added to the barn, right? So this gives you the capacity. Now, real quick, the last ask is to consolidate all the horses, right? So how do we consolidate the horses? So we'll quickly look at that. Public, and then what does it say? It says, say return the number of empty spaces after consolidation. So we'll say public integer consolidate all the horses. Now there are a few ways to do it. We can have two so any guesses on how can this whole thing be consolidated?
We're just moving the horses, right, to make them fit.
Yeah.
Like, okay, so I think that we could have it so if there's empty spaces, so then you just move each horse that's in a space that's not empty after the empty spaces. If that makes sense, you just move it that number of empty spaces.
So
I don't know
let's
that.
say there is
So there's like three, so there's 10 spots, and
yeah.
then there's 3 spots that are taken, like 1, 2, 3. And then there are 3 more spots that are not taken, and then the last 3 are, and then the last 4 are taken. You move the last 4 3 spaces back because that number of empty spaces is 3, if that makes sense.
Yeah. See, the problem here is now let's say if you look at my screen, this X is empty spot, right? And all these ones are where the horses are. Okay. So now
Yeah.
let's say, okay, we find X. Now we need to put a horse here. So how would you do that? So what we want to end up doing is we should have something like such. 3, 5 horses, 4, 5, and then X, X, X. Right? So we need to have that as output. So how would you do that? Now let's say, okay, you find an empty spot, and you keep going in the array and find the spot which has a horse, and then move it there, right?
Hmm.
So this would make it look like that.
Yeah, and then you can just keep doing that, right?
So now you repeat this one more time, and then you'll have 1, and then this becomes 1, and this becomes x,
Yeah,
right?
and then it's like the same way, right? I still just keeps adding up.
No, so now your I is at index 2, right? But your next horse is at index 5. So you need another pointer j, which kind of keeps going till it finds
Okay, yeah.
a horse, and then move that there, right?
Hmm.
Right? You're with me?
Yeah, yeah. So you could put that as like like if j is equal to null, then you just do j plus plus over and over until you find one.
Yeah,
Yeah, okay.
I think, right? So that's uh, yeah, that's an easy way of doing it. So we need two indexes, index I, which keeps track of empty spaces, and then we have index j, which keeps track of filled up spaces, right? So we'll just do that, and then for let's have another variable called k. We really don't need it, or you know what? Actually, we don't need. Say while j is less than our spaces dot length. So j cannot exceed beyond the if spaces at index I is equal to null, then what do we do? Then we copy whatever is at spaces j, right? And then we empty the space j, because the horse was moved from j to I, so that space became empty now, right? Um, that's there. But then um, now before we do this, we have to do while um, spaces at j is not equal to null. Keep doing this till you find a place which is you find a space which has a horse, right? So you keep incrementing j till you find a place where there's a horse, and then you do I plus plus. I think so once that is done, then we say return barn capacity. That's it. Then they should do the trick. Well, so I think we are 5 minutes overdue. Any questions if you guys have? Else, look at this last program and try to see if there's any bug in it and try to fix it. I'll stay back to answer any questions. Else, you all can call it a day and you all have a good night.
Thank you.
Thank you.
Thank you. Bye bye.
Bye.
Thank you.
Bye bye.
Have a good night.